All right, so now let's cover the test of the overall regression. So here we're testing whether all the slope parameters equal 0. So testing if the effect of all independent variables equal 0. So our null hypothesis is that beta 1 equals beta 2 equals ... beta k, if we want to leave it nice and general, equals 0. And our HA is that at least one of these doesn't hold. So we have k number of them, one of these ones doesn't equal 0. That means we could reject this null hypothesis. So just using the R squared formula, our F stat, remember, is the R squared unrestricted minus R squared restricted, if we're using the R squared version of this test for Q. 1 minus R squared unrestricted divided by that second degrees of freedom. Remember, this has a F distribution with Q and N minus K minus 1 degrees of freedom. So this is the formula, but notice here, R squared restricted is from the regression y equals beta 0 plus u. So if we set all the beta 1, beta 2, all the beta k's, all the slope parameters equal 0, this is the regression we're left with. Well, this regression, the R squared of this, like of this regression here, equals 0. I mean, we're basically trying to explain variation in with just a constant, right? We're trying to explain the variation of R squared is about how much of the variation in y you're explaining through a constant. Well, I mean through your regression. Well, here you're trying to just use a constant, so it's going to be equal to 0. Mathematically, we can show that it equals 0. Remember that beta hat here is going to be equal to y bar. Beta hat 0 is just going to be y bar. We're just going to draw a flat line through the mean of all these y's. That's what the regression is going to do. That's what our least squared estimator is. So the R squared here, remember, is ESS, the explained sum of squared, over the total sum of squareds, TSS or SST. Maybe I'll go way over here. Sorry if it's a little bit messy. So remember, R squared equals ESS over TSS or SST. R squared equals explained sum of squared, so total variation in our predicted one, which is going to be this. And then TSS is the variation in our actual y's, and we're summing over all the y's, I should put. But here, y hat I is going to be equal to beta hat 0, which is y bar. So this is going to be 0 over something. So that's why this R squared equals 0. So whenever you're running a test of all overall significance, our F stat is going to look a little more simple than it usually does. And I'm going to try to just erase this stuff below really quickly so we can kind of just write it out right below, as opposed to having to erase the whole board and rewrite it. All right, so hopefully that's not too messy on your side of things. But so now this F stat is just going to be R squared unrestricted divided by Q, 1 minus R squared unrestricted divided by N minus K minus 1. So we don't even need to run our restricted regression, because we know that the R squared of our restricted regression, if we're testing all the slopes equal 0, is going to be 0 because of this. So this is going to be the F stat formula for the test of overall significance. Nothing changes about how you reach a conclusion. We're going to reject the null if if this f stat is sufficiently large. So sufficiently large meaning, you know, kind of where below our threshold for making a type 1 error. So that's the idea here. So everything's the same. We're just kind of, with this test of overall significance, all it's changing is kind of this restricted r squared equals 0.